Thank you. Thank you, everyone. So I'm going to present my work on GPS spoofing attack. My name is Faiyaz Ansari. Um, Talking about a definition of GPS spoofing, specifically in drones or aviation. So it is similar definition with the GPS spoofing. Spoofing is something you do on someone's behalf, acting as if it is legitimate. It might be a signal, it might be a data. So in the context of GPS spoofing, it involves the transmission of legitimate looking false signal. And the objective is to deny the service provided by the GPS for the drones. For example, it may provide false positions, velocity, time, to make any kind of disruption to the drones. So I will talk about two contributions. Uh, Initially, I will be talking about the stride models in the drones, uh, specifically how a spoofing attack, like when a drone is under the spoofing attack, how the other threat parameters are affected, or what others could be exploited. And another contribution is most of the receivers can have a detectors, spoofing detectors. So I have used one of the spoofing detection method, and I have used the dataset uh, and took the dataset in such a way that it could bypass the detection mechanism. So talking about the first spoofing attacks effect in other threads of the stride model, specifically in the drone. So when we are talking about spoofing, we are talking about spoofing the position, velocity, and time of the drones. These are the three parameters we typically are interested when we are talking about the spoofing. And in positions, we talk about latitude, longitude, and height. So let's assume that a drone is an attack, and the attacker is able to spoof the position, velocity, and time. Then what could be affecting tampering, repudiation, information disclosure, denial of service, or elevation of privilege? So first we need to analyze that what could be a tampering situation for a drone. Uh, so a tampering situation in a drone could be like a drone is expected to follow a path, or maybe needs to be uh, fly in a region for 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 uh, for non-commercial. We expect that it fly under the 400 feet. So if an attacker is able to spoof the position, it can make the drones go beyond the altitude, like above 400 feet. And that's a tampering without actually doing anything on the device. But with just spoofing of the position, it could actually tamper the drone to go beyond its predefined or expected reason. Another is repudiation. Repudiation meaning uh, 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 an assessment of the drones. Like a drone cannot deny that I have not done this action. So let's say one of the expected could be uh, a timestamp. So whatever telemetry data or logs it generated, uh, uh, it is uh, it is a best practice that it log with the timestamp. So if an attacker is able to spoof the timing of the drone, meaning like it will spoof the timing of the satellite, and when the receiver calculate the timing, it gives the false timing. So the log is stamped with the wrong time, and if something goes wrong, an assessor will try to see what's happened like let's say a black box. Uh, if an aircraft goes unexpected, and assessor will see the black box and they go with the timestamp. And if the timestamp is wrong, they cannot determine what the actual reason is. Another one is information disclosure. So in drone, it is expected that all the information, especially the confidential informations like data from the sensors or operator locations, need to be secure. So let's say a spoofer is able to spoof the positions, then it can spoof the route of the whole data, whole trajectory. So what will happen is like some drones may be designed that if something unexpected happen, it goes back to the operator. So spoofing the route, and that is the uncertain situation for the drone. So what the drone does is it get return back to the original home or the operator. In this way, an attacker can know where the operator is located. Another is a denial of service. Denial of service is whatever service is provided by the drones, it simply denies. For example, uh, for a drone, we expect that it goes, it flies safely, that it does not go and uh, hit any civilians or any target. So by spoofing the velocity or the position, attacker can make it collide with obstacle. Another is elevation of privilege. So what we expect is that uh, a flight is configured to go in a specific direction or in a specific region, and and only the controller or the operator can make the changes during the runtime. However, a spoofer spoofing PVT value, it can make the drones go into an unexpected region or unexpected velocity. So without actually having a command and control, it can elevate the privileges. And the actions are privileged actions. So in this way, we can also achieve the elevation of privilege. So this is an overview. Uh, so now talking about my second contribution is bypassing the detectors, GPS detectors, GPS spoofing detector. So before that, I will try to give some information so that it will be helpful to understand my contribution. So in a GPS system, at a sender and a transmitter and the receiver, um, so the receiver try to understand who the GPS is, which GPS station is sending me the signal, and that one, and it tries to know because that may be also the one of the reason that someone can spoof it. So these are called CA code, and so it's a pseudo-random noise code. The receiver does not have the exact value, but it's a random value. It's generated randomly, and it's in the form of 0 and 1s. So when the receiver received it, it received the PRN value from the received signal, and it has a pre-generated signal. So after that, it make a comparison. And if they are same, then it consider that, oh, it is from the legitimate satellite. So in this example, we can see that there is a blurred section, like it does not actually matches. So this means that it is a partially correlated. So the receiver is designed in such a way that it could reject such signal. In the second figure, we can see that it has a good matching, and after decoding, it can know which satellite has actually sent me the signal. Code phase. Code phase is another term is the code phase, meaning how the transmitter and receiver are aligned. So the first figure does not show much alignment. The second figure shows good alignment, and it is helps to know the PRM value. And pseudo range. So pseudo range is it helps to calculate the range between the transmitter and receiver. And why is it important? To determine the position, latitude, longitude, and elevation of the drones. So it's the time difference between the transmission from the satellite and the time of arrival in the receiver of a particular signal transmitted. So we are talking about a particular signal, not all the signal. After multiplying the time difference with the speed of light, we can get the pseudo range in a distance. And this helps to calculate the precise position of the receiver. Also, the satellite time could be a parameter to determine the spoofing attack. For example, let's consider that GNSS receiver refreshes its PVT value every 1 second. Now, if the rate of change of time is more than 20 milliseconds with an offset of, let's say, 5 milliseconds, then it could be considered as a spoofing attack. And with this with the pseudo range with the pseudo range, we can actually calculate the distance between the transmitter and receiver, and we calculate in all 3 directions to actually determine the latitude, longitude, and the elevation. So after calculating and using some estimations and filtering mechanism, we can know the actual position. And why it's important? Because a good position will help to determine to detect the spoofing attack. Another is a Doppler shift. It's actually a relative motion between the satellite and receiver. We might have experiences ourselves on a road when a vehicle is approaching towards us. We could listen like the sound more louder. If it is going away from us, we see it like a more fader and fader. And why is it important is this could also be one of the parameters to detect the spoofing. So typically when the rate of change of Doppler shift frequency is more than, let's say, 20 kilohertz with an offset of 5 kilohertz, it could be considered a spoofing attack. So similar to range, we also need at least four satellite to determine the actual direction of the receiver. So this parameter is used to calculate the velocity and the direction of the drone. Power level, yeah. So power level, so what's the power level? So any signal has a power, like an amplitude. So in a GPS system, in the figure here, we can see that 100 minus 111 dBm is the thermal noise. So it is a calculated parameters based on the environment, like a ionosphere, or our environment, like a clouds. So it is expected at the receiver side that when the receiver receives the signal, it should be nearly 20 to 25 dBm below the thermal noise floor. So spoofer usually what they do, attacker usually what they do is like they increase the power of the signal. So when they increase the power of the signal, it is more likely that a receiver will receive the signal. We'll pick the signal for analysis. So, but at the GNSS receiver, if the signal is beyond the thermal noise floor, it will reject. or consider it as a spoofing attack. So instead of power, in GPS system, it uses carrier to noise density ratio. It also measures the signal quality, but it's just a different unit to calculate. But the whole, but carrier to noise density ratio is calculated from the power levels. Okay, so that was some definitions. Hope you guys enjoyed it. Uh, However, I'm going to talk about some GPS spoofing attacks. So first, one could be a power level checks, a measure of signal quality. When the signal quality is so typically what attacker does is they increase the quality, enhance the quality of the signal to spoof this attack because the GPS signal we actually receive has a very low power. So, but when the power exceed the thermal noise floor, it is a measure. It can be used as a spoofing attack detector parameters. Another one is Mekoning spoofing attack. So in this attack, the attacker actually uh, record the or legitimate signals, and then it modifies the parameters. Um, like incorrect times, position, velocities, and then retransmit the signals to the trajectory. And of course, they will increase the power so that they can lure the drones. The third type of attack is synchronous spoofing attack. So in this type of attack, what an attacker does is uh, it generates it generates a signal. It generates the signal similar to the legitimate signal, and after with increased power of the signal, so that the receiver now is able to receive the signal from the attacker. Once the attacker feel a confidence that receiver is listening my signal, not the legitimate signal, then it start changing the parameters and changing the parameters of position, velocity, and time to make it in a different direction. So based on that is my contributions. So my contribution is a GPS spoofing attack bypassing the spoofing detectors. So so most of the attacks are black box attacks, but I choose for the white box. I will explain later why. However, I will first talk about what's a black box and white box. Black box, we do not know any parameter. For white box, we know some parameters. Okay, this is so for detectors. The detector I have used is they uses neural network for training, and I use a Jacobian based silencing map attack to create my data set to bypass the attack. So what happens is like this is just an example. So this is an image of a plane, and what it does is like it maps the features which is more responsible for classifying this object as a plane. And what Jacobi has done is it changes those parameters which are most impactful and try to attack. And they could and such in such a data it could misclassify. So so how I created my data set is I from my test data set I choose one value, and so I from the actual model, from this model where the model is trained, I uses the same model parameters and try to classify. So if the classification is it's a normal signal. Okay, let me take. So what's 0 and 1? Zero is like a normal signal, and one is an adversarial signal, meaning it is able to this is a spoofing attack and this is non-spoofing attack. So when we receive a data point with a label of GPS spoofing and we try to classify, it's obvious for the first time that it will classify it as a spoofing attack. Then using the GSMA, we backpropagate, compute the gradients, and identify the impactful features, and then modify those impactful features using a small value called perturbations. That could be a 0.5, 0.05, and also the sign of the gradient, like whether we need to increase or decrease the value. And using the threshold, whether it matches the threshold. If it matches the threshold, then we continue and send the data and send the same input, modified input to the model and try to classify, unless we get a non-spoofing classification. So using GSMA, we actually use the same data set with a spoofing attack label to classify it to a non-spoofing attack. So this is a whole mechanism. And this is one of the input point with a very small change. So the first one is a normal, adversarial GPS spoofing, and with changing in these parameters, these features, it was able to misclassify. Okay, so here is my conclusion. So we use a stride model to provide an outlook to the threats and its impact. And another one is we use white box to bypass the detectors. Why I use it? Because it can be used to determine the bound of failure, like for which value it could be failure, so that we can create countermeasures for our model. Okay, thank you. I'm happy to receive questions.